Hi folks, and welcome to another session of 52 Weeks of Python. My name is Chuck Black. If you recall, my goal in these sessions is to teach you to become a programmer or a coder or software developer, whatever you choose to call it. My goal is not to give you little snippets of code that you can copy and paste and attempt to use but not understand, but rather my goal is to teach you the skills that are needed in order to understand Python and to write it yourself. And so that's what we'll be doing. If you recall, we are taking a two-pronged approach to this. On the one hand, I am teaching you using simple code examples how to write code to do a particular task, and I'm going to explain that to you in detail. I'm also going to describe to you how I quickly and with a small amount of code built this application that you're looking at right now, which I've called Quokka. Now, over the course of weeks, you will notice Quokka changing a bit. That's because it's a work in progress. I'm building and changing and removing and adding stuff as we go. As you can see over here on the right, what I've done in the last couple of days is I'm not only recording availability and response time for services and hosts on a minute-by-minute basis, but I'm also storing hourly averages. The usefulness of storing hourly averages is that I can then set a baseline or a service level agreement line, and I can detect when and how often a particular service or host or whatever is meeting those service level agreements or failing, and then we can log errors if it's failing. So you can keep track of the behavior and the response time, availability, etc. of your devices and hosts and services in the network. So it's kind of handy. And it's pretty simple to do. So in the course of me going through all of the Quokka stuff, I'll be touching on that as well. But let's get started as we do every week with the lesson of the stuff that I'm going to teach you. So without further ado, let's go to that part. Okay, folks, so let's get started with this lesson. Now, if you recall from last week, we talked about the very, very basic stuff, such as what is a variable. We talked a little bit about dictionaries and lists. We talked a little bit about printing. We talked a little bit about for loops. We'll be using those as we go through some Python stuff in a little bit more detail. And specifically, the domain that we're dealing with things is a networking domain. So I have defined in this example here a device. And device is my variable name. And I'm going to assign it this equals. If you see 1 equals, that is an assignment operator. I'm going to assign to it this thing that I'm highlighting right here. Now remember, this thing that is highlighted nicely for me by PyCharm, the curly braces, if it's on the right-hand side of an equal sign, it is most often going to be used to represent a dictionary and to define a dictionary. And more specifically, if the items have 2 items, a key and a value, then this is going to be a dictionary. You can have a different data type in Python called a set, but that doesn't have keys and values. So we're really going to be looking mostly at dictionaries in our examples. Now, in this situation, I'm defining a dictionary. It has a key called name, and this is the value that I'm associated with the key called name. It has a key called vendor, and the value of that is Cisco. It has a key called model, and this is the model Nexus 9000. It has a key called OS, representing the operating system, a version, and an IP address. So I have defined my device dictionary to have these values. Now, the first thing I'm going to do is I'm going to print this out. So what I'm going to do is I'm going to let this run, and then we're going to look at the output. So we're looking here at simple print. This is the stuff that I have right here. Let me leave device there for you. This is this code, simple print. This is the output of that. So when I come down here, the first thing I'm doing, I'm just printing out this line. You notice I'm using double quotes. You can use double quotes or single quotes, but they have to match. That's the only thing. And so I'm just printing out this string. One thing you may be looking at and saying, hey, wait a minute, what's that \n? Well, \n says, give me a new line, please. So basically, if I hadn't done that, this would have been up at the top. So it's just helping the readability. So what I'm doing first is I'm saying print out, and this is the string that I'm printing, device colon. You see that string part right there. And then I'm printing out the actual variable. Now the variable in this case is what? Curly brackets and the colons tell me that this is a dictionary. So it's going to print out a dictionary. And sure enough, I can see that it printed out this dictionary. And if I were to scroll far over to the right, I would see all of the values. Now that's not a very friendly way to print it out, but you've gotten the idea that that's what that is. Now, what's the value of a dictionary unless you can refer to various items within that dictionary? And that's what I'm going to do here. If I want to look at the device name that I've defined, how do I do that? And the way that you do that, the way that you dereference everything in Python, whether it's a list or a dictionary, is you put inside these square brackets the subscript or the key that you're going to use to reference that. Now in our situation, device is what type of data structure? It is a dictionary. So what I will be providing inside these square brackets is going to be the key. Now the key that I put in there was name, and that's why this is successful. If I was to put something different that didn't exist, it would throw an error for me. But you can see over here, I printed out device name, and here's my output of device name. And then I say print out this device dictionary, the value associated with the key called name. The value associated is SBX N9KVA0, and sure enough, that's that exact value. So here's a definition of a dictionary and also dereferencing a particular value within that dictionary by providing the key, and we provide it within square brackets. Now you may be asking yourself, wait a minute, Chuck, I think I recall last week you said something about square brackets referencing and meaning that we're talking about a list. And if I had used square brackets here and defined something, then that would have been a list. But you see, the definition of the thing is different than the dereferencing of the thing. So in the one situation, I have an equal sign, and then I set it to this value. If this was a list, this would be square brackets over here. But in both cases, when I want to dereference that data structure device in this situation, since it's a dictionary, I'm going to put within the square dereferencing characters here, I'm going to put the key that I'm referring to. Hopefully that makes sense. All right, what if I wanted to print this device thing? Remember we said this was kind of ugly here? What if I wanted to print it in a little bit nicer fashion so it's more human readable? Well, I'm going to do something. Notice here, I'm not doing a print, I'm doing a p-print. Now what is p-print? Remember we said last week, or the last time that you watched this, that print is actually a built-in function that we can call in Python. But this time I'm using p-print. That is not a built-in function. And if you had an eagle eye, you may have noticed something that I didn't mention, but that was up here at the very top of our file, and that is an import statement. And here I'm saying from this external library called pprint, it's actually in Python we call that a module, but sometimes people refer to these things as libraries, so you can put that in your brain, and when people say libraries in Python, they're typically referring to a module. From pprint, I want you to import the function called pprint. Now, there could be other functions within pprint, and they would have a different name here, so don't get thrown. This is not always going to be the same name, and we'll see that in the Quokka code over and over again. But that tells Python, hey, whenever you see pprint as a function, this is what it's referring to. So Python says, aha, pprint, I can go up to this module called pprint and pull in the code to execute it. And all I'm doing is I'm passing in my device. Remember what device is? What type of data structure is that? As you can see down here, yes, it is a dictionary. So it's going to take this dictionary and it's going to print it in a more pretty manner. In software parlance or terminology, we refer to that as pretty printing, and that's why it's called pprint. And here you can see the dictionary. It's gotten printed in a much nicer manner. Now, if you have more complex data structures like a dictionary of lists, and those lists each have a dictionary, etc., then this could be handy for just printing stuff out in a way that is easy for you to read, especially when you're debugging stuff. So pprint is something that you see people use quite often, especially when they are building code. That will be your friend. Now, the last thing that I want to show you is what if we were not satisfied with this because we want it to be human readable. If you showed this to your boss, he'd probably be able to figure it out, but he'd go, what's with all this funky stuff like curly braces and colons and quotation marks and all the other stuff? Why didn't you print it as a human would read it? And so if you wanted to do that, there are many ways to do this. I'm going to show you a simple but powerful way to do it. It makes use of some of the newer stuff that's come along with later versions of Python, specifically the idea of an F string, which stands for a formatted string. Some people call it a friendly string because it's very easy to use. So we're going to be looking at a couple things here. First of all, let me show you the output just for kicks. Here's our output. You can see, you know what, that's a pretty nice looking output, right? I mean, you could put that on a report or something like that. There's room to the left and to the right for various things. It lines up nicely, and you may like that. I like that. That's why I did it. Maybe you don't like it, but you're stuck with it because that's what I chose. So let's look at how we did this. What we did is something that's a little bit advanced, so hang on to your seat for a little bit. Now, we talked about for loops last week, and we said that for loops in Python were really good and really handy when you want to iterate through something that is iterable, like a list or maybe reading lines from a file. So that is what we typically do. This is a little bit more advanced because remember, let me ask you again, what type of data structure is device? This is giving it away. It is a dictionary. Dictionaries are iterable, but you have to do something special to it in order to make it iterable. Iterable means you can go through it one after the other, after the other, after the other. And so the way that you do that is we are going to call this function on device called items. And what that is going to do is items is basically going to create an iterable list of dictionary items. What are my dictionary items? Here's one dictionary item right here. This first one right there. Here's another dictionary item right there. Here's a third one, right? These are all dictionary items. And if you're looking at this and you wanted to get these one at a time, you'd say, well, it's going to give me two things. It's going to give me the key and the value. And that is correct. And when we go down here, I'm just calling it any variable name. You see these things in white. It refers to the fact that this is just a variable name. I could have called it K and V. I could have called it a dictionary key. I could have called it Fred. Whatever I wanted to do, I could call it. But for easy readability and understanding it, I call it key and value. And so I'm going to iterate through this dictionary one line at a time. And for every one of those, this is the statement that I'm going to execute. So I'm going to do this for every one of these lines in my dictionary. And so what I'm going to do is I'm going to do a print statement. And you can see over here, here's the output of the first line. Here's the output of the second item. Here's the output of the third item, etc. Now let's look in a little bit more detail at what I actually did. Instead of using a regular string, you see this F that's in front of the quotes? I'm going to say this is a formatted string. And what that means is I can put whatever I want in here. I can put this is just a string, but it has these extra values in here, and it's going to print these out in this manner. If I was to run this again, you would see all it did was print it out. This is just a string. But one of the nice things about using an IDE such as PyCharm is I'm just going to do Control Z to get rid of that and go back to where I was, and I'll run it so we're back to where we were. So what is this doing? The first thing you see are curly brackets. If it's not in curly brackets, like the text that I put there, you can see that it's green. It's just part of the string, and it's going to print that out like I did before. If it sees curly brackets, if Python sees curly brackets, it's going to say, oh, hang on a minute. I'm not going to print this out. This is going to be a variable name. And my variable name is key. You see, this is the value that I got from the dictionary. And then the second thing I printed was the value. And so it's going to be key. And then remember, this is just part of the string. You can see that it's green. Of course, the space isn't green, but the colon is green. And you can see that that is what is getting printed right here in between the two different pieces of data that I'm printing out. The second piece is value. I'm just printing out the value. I did something special when I printed out the key. When I printed out the key, I gave this special stuff which says, I want you to give me 16 characters of string, and I want you to write justify it. So just for kicks, if I were to get rid of this, so I'm going to do this, and I'm going to backspace, and now I'm going to print it out. You can see what it looks like. This isn't so bad. This isn't terribly bad, but I kind of like when the colons line up better. So I'm going to go back here to this side. I'm going to do Control Z and hope that it remembered it. And now I'm going to print it out, and it looks nice. Now you can play around with lots of different ways to do this, and we'll look at some of those. But this is just a simple way to print out our little device that we've created and that we're beginning to use in building Python code that actually does something, and hopefully you guys understanding what it is that we're talking about. That's it for this device lesson. Hopefully it makes sense, and hopefully you are beginning to get a better idea of what this Python programming language is. And I also hope that you're beginning to see that this is a lot of fun. Okay, folks, so it's time to turn our attention towards Quokka, not this little animal here, but the project that I wrote a little bit of code to manage and monitor, and maybe even in the future as I build a little bit more into it, configure devices, hosts, and services in a network. So I showed you a picture that looked something like this before, but I've added a little bit more detail because at a high level, we're going to look a little bit more at what exactly Quokka is and does. So I mentioned over here on the left, we have a database. Down here at the bottom, there are devices in the network, there are hosts, there are services that we're monitoring. Up here, there's the user interface. The user interface, I think I've shown you before, looks something like this. You can look at your devices, get a list of them. When you drill down into devices, you can get information about the response time, CPU utilization, availability, and memory utilization for that device. If I go over to hosts, I'm showing you a number of hosts that I've discovered in the network. If I go over to services, I'm showing you services that I've configured that I am monitoring. The services can be doing DNS, HTTP, or NTP. For now, I may add some more services. And when we drill down into these, I think I mentioned that I added a little bit of extra stuff to make it more interesting. We were doing response time and availability the last time I talked to you. What I've done is I've added hourly response time and availability. When you have hourly totals, then what that allows you to do is look at availability. Say here, this BBC News service, I can see that during the course of this entire time, the availability hour per hour has ranged from 40 up to 100%. And so if you can imagine a line being drawn here, that would be the service level agreement that might exist in your environment, then you can tell, okay, is this service meeting the agreement or not? And then you can have some negotiations based on that. You may look here and say, well, why is there that long straight line? Where's this? Why does it look like that? Well, if you notice, this is actually the time that this service was not running. So from about 3 in the afternoon, I had the service down all the way up till 6 a.m. or 7 a.m. in the morning, I brought it back up again. So anyway, it's just recording that stuff. I did turn it back on and it is running right now. But let's go back to this picture of the architecture. What I want you to understand is the amount of code that I myself has written is very, very small. It doesn't even deserve a big box next to all of these other components that I've put together and that are working together in order to achieve what it is that we're doing. So let's look at some of these. So we have a database. How do we talk to the database? Well, there's a library or Python library that has been written called SQL Alchemy. It's not the only one, but it is one, and it's for dealing with SQL databases. That's a particular type of relationship-oriented database. And so this actually plugs into Flask, which is the whole application service that's running here. All of these things are running at the behest of my application that's running within Flask. So I have SQL Alchemy stuff. Now I've separated out this REST API that actually comes with Flask itself. And so let's see, I moved that inadvertently. So that actually is part of Flask. One of the main deals with Flask is it allows you to have a web service running. And so part of that web service is the ability to provide a RESTful API. And this is what we're using to allow the user interface to get at that database information that we're storing. So that's the main idea of that. Now for going out and talking to networking devices, you'll see I had, if you remember, I had devices and I have devices, I have hosts, and I have services. And the part for talking to devices is going to be the one that we're the most interested in because that's the domain in which we can do the most stuff. We can actually look at details of the configuration of those devices. We can look at traffic counts, etc. So this is how come it has a place of importance in this diagram. Napalm is what we're using. Napalm is a nice abstraction layer that allows me to say, get me the version for this device, and I don't care if the device is a Cisco device or a Juniper device or an Arista device or even an HP device or whatever it might be. It has knowledge built into it and is continually adding more that goes out and does either SSH or in some cases netconf to the devices and returns the information appropriately. And like I said, my little piece of code that I'm going to be describing to you over the course of our weeks together is running inside this Flask environment. The last thing I'll point out here in this slide is that I've provided more detail about what's going on in this Node.js service that is running. And what you can see up here, I've written that on this line right here, this is the Quokka content. That is the actual data that you see on these particular screens. So not the graph itself, but the data behind the graph, the data behind whether this is green or this is red, the information behind. If I go down to my particular device here and I say, give me the facts for this device, this is all getting retrieved effectively using that mechanism that is right here. The user interface is going to this Flask, this Quokka service that's running using REST, and it's saying, get me the facts for this particular device. And it goes to the database or to the device and returns it. So that's the content side of it. The screens, that is the prettiness of, this is a table, this is a layout that has an application bar with the little menu thingy. I've got these buttons for going to different areas. I can click on services. It draws me a table. The table has the ability to be paginated to sort things based on various items here, etc. That's all part of what the user interface is, and that is coming from these Quokka screens and the functionality there. So my screens are actually code that I've written a little bit of JavaScript code, as I mentioned before. I've never written JavaScript code before. This is my first attempt, and that's not the purpose of this class, but I've written a little bit of it. I'm making use of this React framework, which is contributed by Facebook, and I'm using the Material UI, also libraries and modules and functionality that was contributed by Google. So I've written a little amount of code here, and it's mainly, I did not write the stuff to do the table. I did not write the stuff to sort the table. I did not write the stuff to do the nice graphs that you look at. What I did do is I wrote the code to go get the information and to provide that information. So I wrote the code to go and use this REST API to get the information and then to populate the graph with the appropriate information. So that's in general what it is that we are looking at. I'm going to minimize this, and what I'm going to do now is I am going to make this bigger so that we can look at the code. Okay, so here we are at the actual Quokka code, and I'm going to give you a very high-level overview of what's going on. Remember, in that picture, let's see if this comes up successfully when I look at my slides. When we are going out and getting the data, that is using this path right here from the user interface to go get particular pieces of data, what is actually happening here? Well, the thing that's happening here is that requests are going to come in to our application that is running inside Flask, and it's going to get routed depending on what the URL looks like. This one here is called devices, so the URL that I'm using to make my RESTful request is devices. If I go down here, you can see here's where I'm getting information about a particular single device. That's where I'm getting information that is common related to a particular device. Here's my host screen. Here's my event screen. If I go down towards the bottom, you can see here is the screen where I'm getting the service summary. That's actually what exactly we were looking at when we looked at all the 4 graphs that were related to that. So the amount of code that I've written for implementing this starts out, it's really pretty small. What I'm going to do is I'm going to be returning this information. Now, I am going to be returning Python data, but it is going to get translated by Flask into JSON data, so you don't have to worry about that. If I was to look at one of these things, this is remember, let's just look at this really quick. These curly braces with the stuff inside having a colon separated, what does that mean that this is going to be? You're correct. This is going to be a dictionary. So I'm returning a dictionary, and for the purposes of Flask returning it on a REST call, it's going to get translated into JSON formatted data. But for my part, all I have to worry about is the actual Python that I'm creating. So my Python dictionary has 2 items in it. The first item has a key called service summary data. The second item has a key called service. Now, this is more than I've talked about in our class so far. So for those of you that don't understand this yet, don't worry, we're going to get to this. For those of you that do, you can see, oh, he's just making a call to this function that he must have created called get service summary data. And so what I'm going to do is I'm going to take you to that. Now, one of the nice things, besides all the cool color coding and the helpful information that you see, is that I can click on this and I'm doing a Control B. You can't obviously see me doing that, but when I do a Control B, look what happened. It took me directly to that function that I have defined in this APIs module. And again, if this is new to you, don't worry. I'm going to be spending the next 51 weeks or whatever going over this same stuff. I do like to keep it simple, so you will have multiple opportunities to hear me talk about this. This is a function. We're not going to go into all of what that is, but this function right here is going to just go to the database. This is where I make my database query. So remember, I said that the REST request is going to come in, and then in certain situations, I'm going to go out to the database, get information, and then return it back. That's basically what our application does. So I'm making a database query. If you just look at this, you can say, okay, I'm getting it from the service status summary table. I am going to filter it by the service ID. So when you look here, you can see I'm getting information for a particular service. This is just one service. So when I actually make the request, I'm passing in the service identifier. That helps it to get it from the database. What I'm doing with that data that I'm getting at all this hourly data, the summary data that I've gotten from the database, I'm going to sort it and I'm ordering it by timestamp descending. That's because I want to get the most recent certain number of items. And that certain number of items I'm specifying by doing .limit. And here I'm saying limit by the num data points. Now, the num data points was something that I received on this request. So the request, the HTTP request came in. Remember, we're back up here. This is the REST request. It's a GET request. And one of the arguments that was passed to me was the number of data points. Now I've got it hard-coded inside my user interface to always get the most recent 24. So if I end up running this for weeks or months in my current situation, I'm getting the last 24, which is the last 24 hours. You can obviously modify that. And then I'm returning all of these. And then when I go back to the views, I'm going to be doing this for the service summary data and for the service information that I'm going to be returning. So this is what I've implemented for my Quokka. I've given you a very high level view. Let me return you to this picture right here that shows you a little bit. I will be going into some of the JavaScript stuff, but we're focused mainly on the little bit of Python code that I've written in Flask. I've given you a little bit of a taste of what happens when a request is made that comes in via HTTP. We go out to the database and we return it. Now, obviously, a whole bunch of stuff is going on in the background where I'm getting information about devices, hosts, and services. We'll be talking about that at a later point in time. Hopefully this gives you a good indication of what's going on with Quokka. Thank you for listening. Remember, this is a Quokka that is native to the west coast of Australia, either that or it's David Bombal before he's had his cup of coffee and a shave in the morning. Thanks for listening.